All right, so today we're going to talk about molecular formulas. Not empirical formulas, but molecular formulas. We talked about how in empirical formulas, they're supposed to be the most reduced version of a chemical compound, right? Empirical formulas are the most reduced version of a chemical compound. So when we look at molecular formulas, they are basically the non-reduced chemical compounds. My iPad is having some trouble. Non-reduced chemical compounds. So if we look at an example we did like on our worksheet yesterday, C6H6, you were supposed to reduce it down to an empirical formula. Its empirical formula would have equaled just CH, right? We would have reduced those sixes down to be the most reduced version, and the empirical formula would have been CH. But this C6H6 would be the molecular formula, right? It's a non-reduced version of a chemical compound. That's really it. Okay, so another version of this empirical formula as a molecular formula could have been C2H2 or C4H4, right? Any version of CH that keeps the ratio of 1 to 1 would be like a molecular formula of CH. Does that kind of make sense? As long as it's got the same ratio, it would be a molecular formula of that same empirical formula. Okay? So when we talk about molecular formulas today, we're going to look at, well, what version of the empirical formula are we talking about? Are we looking at an unknown that has a formula CH? Or are we looking at an unknown that has C2H2? Or are we looking at an unknown that has C6H6, right? We know the ratio of carbons to hydrogens, but then we're going to find out, well, which version of that empirical formula are we looking for? Okay, so molecular formulas are non-reduced. The way that we're going to find an object's molecular formula, we're going to just kind of walk through an example here. There's not a big, long set of rules like there was to find empirical formulas. We're just going to walk through. Okay, so the first one we're going to try, it says, the empirical formula, I'm going to kind of just abbreviate these down. The empirical formula of a compound is P2O5. The molar mass of the unknown compound is 283.9 grams per mole. What is the formula? Okay, so we have an unknown, and we know what the empirical formula is, but we don't know what's the molecular formula. All right, so we know that the empirical formula, or we know what the ratio of oxygens to phosphorus has to be, right? The ratio's got to be 2 phosphorus for every 5 oxygens. But we want to find out, well, what version? Are we talking about P2O5, that's our unknown? Or are we talking about P4O10? Or are we talking about P, 20, right? Are we talking about any of these versions of this compound? That's the goal, is going to be to figure out which one it is. So the way we figure it out is we find out, okay, what's the molar mass of our empirical formula? Okay, we want to know what's the molar mass of our empirical formula. All right, bless you. So I want to find molar mass of empirical formula here. So phosphorus, look for phosphorus on the periodic table. It has a molar mass of 31 times 2. Oxygen has a molar mass of 16 times 5. So you do need your calculator out today. If you don't have that out just yet, go ahead and grab that. You'll need your molar mass side of the periodic table, not your ion side. I had a molar mass of 142 grams per mole. Agreed? Okay, 142 is what I had for my molar mass of my empirical formula. And so now to figure out what version we're dealing with, we're going to take the molar mass given to us in the problem. We know that our unknown compound has a molar mass of 283.9, and I know my empirical formula has a mass of 142. So the way I'm going to solve is I'm going to take the molecular formula, molar mass, divided by the empirical formula, molar mass. And it's going to tell me, well, how much bigger is my molecular formula than my empirical formula? So 283.9, divided by 142. This should give us a nice, round number, or very close to a nice whole round number. Comes out to 1.99929, right, which is 2. So what this does, this 2 tells us that my molecular formula is 2 times as heavy as the empirical formula. Right? It is twice as heavy. The unknown weighs 239, but my empirical formula weighs 142. So my unknown is twice as heavy as my empirical formula. So then I come over and I bring my empirical formula and I multiply it all by 2. Okay, so let me give myself some space up here. I'm going to take my empirical formula, P2O5, and I'm just going to distribute. I'm going to multiply the whole thing by 2, and I get a molecular formula of P4O10. The ratio is still the same. It's just a non-reduced version of that empirical formula. So this would be my molecular formula. And I'd want to make sure I label that as so. Okay, that would be my molecular formula. So I was given an empirical formula and I was given an unknown molar mass. And I find my molar mass of my empirical formula. Then if you can't remember which is which, always divide the bigger by the smaller. Right? The molar mass of the molecular formula will always be bigger or the same than your empirical formula. Okay, so you're going to take molecular formula molar mass divided by your empirical formula molar mass, and that will give you your ratio. Then you apply that ratio to your empirical formula. Okay, when you can't remember, just take bigger divided by smaller. Okay, what questions do we have about that one?
Will we ever have carbon, boron, oxygen?
Yep, and if it would have had another compound in here, P2ClO5, our final would have been P4Cl2O10. Right? It would have been the same approach. We would have distributed that all the way through there. Okay? Good question. Determine the molecular formula of the compound with the empirical formula CH if the unknown has a mass of 78 grams per mole. Okay. We want to find the molecular formula. So we can kind of get to some steps or some rules, but the first thing we're going to do is find the molar mass of the empirical formula. Okay, so if you want to write that out, that's fine. Molar mass of empirical formula is step 1. Okay, and in this case, the empirical formula is CH. And so finding the molar mass of that is really simple, right? Carbon is 12, hydrogen is 1, so molar mass is 13. Okay, 13 grams per mole. If you want to go into step 2, right, if you liked having kind of steps laid out for you, step 2 is divide molecular formula by empirical formula, molar mass. Okay, so that would look like this. The molecular formula molar mass is equal to what? 78, right? Because that's given to us in the problem. So I'm going to take 78 divided by 13. And I get 6. So what that tells us is that our unknown is 6 times heavier than our empirical formula. Okay, so if you like to have your steps again, we would say step 3 is distribute through the empirical formula. So I would take 6 times CH. You don't have to write it out like that, but all it gives us is C6H6. All right, this is our final answer. 6 is not our final answer. Right? That's not how we would give our final answer. Our final answer is telling us that our unknown is 6 times heavier than our empirical formula, which would equal C6H6.